Hi, you are welcome to our YouTube channel. Today we'll be looking at technical evaluation of centrifugal pump mechanical data sheets with respect to API standard 610. Technical evaluation of centrifugal pump mechanical data sheets with respect to the API standard governing the basic design of centrifugal pumps, which is API standard 610. So before we continue in the technical evaluation of mechanical data sheets for centrifugal pumps, you also need to be familiar with other standards that are followed for pump packages. We have the following applicable standards. We have API standard 610, API 610, which is the standard follows for centrifugal pump for petroleum, petrochemical and natural gas industry. We also have API standard 674, which is the standard for the positive displacement pump, specifically reciprocating pump. And then API standard 675, which is the control volume pump, another classification of positive displacement pump. We also have API 676 for the rotary pump, which is also positive displacement pump. And then we have API standard 681 for the liquid ring vacuum pumps. And then we have API 685 for the sealess pump. So these are the following applicable standards for other pump packages. So the attention for today is going to be on API 610, which is the centrifugal, which is the standards for the centrifugal pumps used in petroleum, petrochemical and natural gas industry. So we will be looking at some of the basic design conditions as stated in API 610, so that you can actually carry out technical evaluation of mechanical data sheets for centrifugal pumps before procurement is made. So there are basic design conditions specified in API 610 which governs the design of centrifugal pump. So all pump manufacturer has to follow, they have to follow some of these basic design conditions. So we are going to be looking at some of these design conditions one after the other, and we'll be making reference to some of the clauses as stated in API 610 with respect to mechanical data sheets. So number one thing that I want you to understand is that as per API 610, in one of the clauses, it said the equipment covered by this international standard, that is the equipment, the pump, the centrifugal pump covered by this API 610 shall be designed and constructed for a minimum service life of 20 years. So that is the centrifugal pump that will be covered by API 610, shall be in the API 610. When you see the word shall, that means it is mandatory. So it is expected, it is mandatory that the equipment, the pump that will be designed as per API 610 should have a minimum service life of 20 years, excluding the normal wear parts as identified in table 20 of API 610. And API that table 20 actually contains list of recommended spare parts for startup and normal maintenance, such as wear rings, your bearings, your mechanical seals, your packing, your shaft sleeve, your oil filters, your gasket chims and O-rings. So the centrifugal pumps that is designed by this API 610 is expected to have a minimum service life of 20 years, except those normal wear parts as indicated in table 20 of API 610. And at the same time, this equipment that will be designed by API 610 is expected to have at least 3 years of uninterrupted operation. So it's expected to have at least 3 years of uninterrupted operation. So that is one of the very first clause in API 610. So another clause is that the purchaser shall specify the operating conditions. So if you are going to be the purchaser for your centrifugal pump, so the purchaser shall specify the operating conditions, the liquid property, the site conditions, and utility conditions, including all data shown on the process data sheet. So if you see in a typical mechanical data sheet, which I'm going to show you now, in a typical mechanical data sheet, this is a typical mechanical data sheet which you have here. You are going to have the various operating conditions. Like you see in this case, the operating conditions, you have your liquid handle. The liquid handle is going to be specified what type of liquid your pump will be handling. The pumping temperature is going to also be specified. So these are the operating conditions. Your specific gravity at what temperature is going to be specified. Your vapor pressure is going to be specified. The viscosity of the fluid must be specified. Now the capacity, the normal and the rated capacity must be specified. The discharge pressure will have to be specified. The suction pressure will be specified. The differential pressure is going to be specified. The differential head at rated capacity is going to be specified. The NPSH A, which is the net positive suction head available, which is your system characteristics, is going to be specified. So as per API 610, it is expected that as a purchaser, you specify what? You specify the operating conditions, you specify the liquid properties, you specify what? You specify your site conditions and your various utility conditions. So this is as expected, in API 610. So as a purchaser, you specify, the operating conditions, you specify the liquid property, you specify the site conditions and the various utility conditions, on the data sheet. The purchaser represents the owner or owner agent who issues the order and specification to the vendor. So as a purchaser, it is expected that you specify all this information in your process data sheet. So these are the following operating conditions that have been specified. The liquid properties have been specified in terms of the specific gravity of the fluid, the vapor pressure of the fluid, the viscosity of the fluid, and whether the fluid is going to be having solids in suspension or not. So this and the type of liquid that the pump will be handling. So this and many other things we have to be specified, as per API 610. Okay. Now next is that one of the clauses, as per API 610, is that this equipment, this particular centrifugal pump, shall be capable of operation at the normal and rated operating points. Let me repeat this. The equipment shall be capable of operation at the normal and rated operating point. As a purchaser, you have specified to the vendor your operating conditions, and part of the operating conditions is going to be what? You are going to state your rated capacity, you are going to state your normal capacity. So it is expected, as per API 610, that the equipment the vendor is going to supply to you shall be capable of operating at that normal, and rated operating points that has been specified by you as a purchaser on the process data sheet, and any other anticipated operating conditions that you must have specified as a purchaser. This is very, very important. So these are the things that you check for when you are carrying out technical evaluation of what, of mechanical data sheet for a particular centrifugal pump. Let me repeat this: the equipment that the vendor will be supplying you, the intended vendor is supplying you, shall be capable. And remember, I told you, as per API 610, when you see the word shall, it means it is mandatory. So the equipment shall be capable of operation at the normal and the rated, you see, the normal and the rated operating points which you have specified. If you see in the mechanical data sheet that I showed you the other time, now look at this. The capacity here for the normal capacity is 290 cubic meter per hour, while the rated capacity is what, is 320 cubic meter per hour. So it is expected that the equipment the vendor will be supplying you shall be capable of operating at this normal capacity and the rated capacity. This is very, very important. Okay, now so the next thing is the pumps shall be capable of at least a 5% head increase at rated conditions. This is as per API 610. So these are some of the basic design conditions that governs the design of centrifugal pumps as per API 610. So now your pump that the particular vendor is supplying to your plant is expected as per API 610 to be capable of what, at least a 5% head increase at rated conditions by replacement of what, of the impellers with one of larger diameter or different hydraulic design. Now the question is, how do you check whether a pump is capable of what, at least a 5% head increase? There is an expression which you need to follow when you receive a particular pump curve from a vendor. Your mechanical data sheet is going to come with a pump curve. So you need to check some of the things you need to consider when you are carrying out a technical evaluation for a particular centrifugal pump, is that your pump shall be capable of at least a 5% head increase. Now, how do you check whether a particular pump that a vendor is supplying to you, is capable of that 5% head increase? So you are going to check pump acceptability in terms of 5% head increase by checking your head at maximum impeller diameter over head at rated impeller diameter minus 1 into bracket times 100%. I repeat, you check for pump acceptability in terms of what? In terms of 5% head increase as specified in the basic design conditions in API 610 by using the following expression, that a 5% head rise equals to head at maximum impeller diameter over head at rated impeller diameter minus 1, all in brackets, times 100%. Now for this case, look at this. Now let's check one of the pump curve. Now if you look at this pump curve for this particular mechanical data sheet, now look, now you want to check whether a particular pump that is being supplied to you by a particular vendor, has met that 5% head increase. We said you check for the pump acceptability for 5% head increase by taking the head at maximum impeller diameter. Now if you look at this, now these are the pump curve. Remember in the previous session we said a particular pump curve, we have curves for the maximum impeller diameter, the rated impeller diameter, and the minimum impeller diameter. So in this case, this is the pump curve for the maximum impeller diameter. Now this is the pump curve for the rated impeller diameter. Now the head at maximum impeller diameter, you check, for a particular centrifugal pump curve, we already discussed this in the previous uploaded sessions. So if you are yet to see how to read centrifugal pump curve, you can check some of the previous sessions that have been uploaded. Okay, so now a typical centrifugal pump curve, we have the pump head plotted on the vertical axis with the pump capacity plotted on the horizontal axis. So in this case, the head at maximum impeller diameter, so you come to the pump curve for the maximum impeller diameter where it touches the head. So where it touches the head here is going to be the head at maximum impeller diameter. So in this case, you have your head at maximum impeller diameter to be somewhere around 179.5 meter head. Okay, now while on the other hand you have the head at rated impeller diameter. The head at rated impeller diameter is going to be here. So you look at the pump curve for the rated impeller diameter. Now in between here you have about 4, right? So here is going to be 120, then 124, 128. So you have the head at rated impeller diameter to be somewhere around 128 meter. So now you are going to take, so if when you are checking, you see, when you are checking the 5% head increase, the 5% head increase will now be that your head at maximum impeller diameter, which is around 179 over the head at rated impeller diameter minus 1 all into bracket times 100%. When you use these values, in this expression, once you have value greater than 5%, that means the particular pump that the vendor is about to supply to your plant has met this condition of 5% head increase as specified in API 610. On the other hand, if by the time you put those value 179 over 128 minus 1 all into brackets 100%, and you get value less than 5%, that means you are going to comment on the particular mechanical data sheet that a vendor has supplied to you, that please review that this particular pump is not meeting the clause 6.1.4 for a 5% head increase as specified in API standard 610. So you now wait to see the response of the pump vendor towards that comment you have specified on the mechanical data sheet. Don't forget, I said if you put the values, that is the head at maximum impeller diameter, and you put the value of the head at rated impeller diameter divided minus 1 into bracket times 100%, and you get value greater than 5% head increase, that means the pump has met this particular condition of 5% head increase, and that is okay. Now the next thing you will check for during the technical evaluation of mechanical data sheets for is a particular centrifugal pump, with respect to API 610, which is the standard governing the basic design of centrifugal pumps, is that you are going to know, as per API 6.1.8, the vendor shall specify on the data sheet the NPSH, which is the net positive suction head required. It's your pump characteristics. We have looked at this, in our previous session. So the vendor shall, so it is compulsory that on the pump mechanical data sheet, the vendor shall specify on the data sheet the NPSH based on water at a temperature of less than 55 degrees C at the rated flow and rated speed. Now, if you look at this particular mechanical data sheets, you see the NPSH, which is the pump characteristics. Now, the NPSH has been given to be what? The NPSH required, the net positive suction head required, has been given to be what? To be 2. So it is compulsory. It is compulsory that the vendor shall what? Shall specify on the data sheet the NPSH. If the vendor did not specify on the mechanical data sheet, you have to comment, on the data sheet that please supply the NPSH based on water, and you wait for the response that the vendor will give you. So as per API 610, which is the standard governing the basic design of centrifugal pump, it is expected that the vendor shall specify what? On the data sheet, the NPSH. Don't forget, you as a purchaser, you must have specified the NPSH, which is your what? Which is your system characteristic on the process data sheet. So now the next thing during the technical evaluation of this mechanical data sheet is that you are going to check the margin of safety for cavitation by checking the difference between the NPSH value of your system characteristic and the NPSH value of your of the pump characteristic. Usually this margin of safety shall be greater than 0.6 meter. In some plants you can say greater than 1 meter. So you check the margin of safety for cavitation, because your NPSH must be greater than your NPSH to do what? To prevent, in order to prevent cavitation. Now let's look at this particular mechanical data sheet and see what we have. For our system characteristic, we said for this particular mechanical data sheet, the NPSH at grade level is given to be 4.8 meter. If you check down here, the NPSH, you see at pump center line, we are going to use NPSH at pump center line. The NPSH at pump center line is 3 meter. Now let's look at what the NPSH is. The NPSH, you look for your NPSH is 2 meter. So now as per API 610, the margin of safety, because in that one now is 3, the NPSH is 3, the NPSH is 2. So the margin of safety for that particular mechanical data sheet is 3 minus 2, and that's going to be what? That's going to be your 1. So which is okay. All right, some plants can still accept 0.6 meter, but anything less than 0.5, 0.6 you don't accept, because cavitation in the long run will set in during the operation of the pump. Okay, so some of the things you check for during the technical evaluation of what? During the technical evaluation of centrifugal pump mechanical data sheet is that you check for margin of safety for cavitation by comparing what you have as NPSH value, which is your system characteristic, the net positive suction head available, and you look at the NPSHR, which must have been specified by what? By the vendor on the pump mechanical data sheet. So you check for the difference, between the two. So in this particular case, you have 1 meter, so which means it's okay. All right. Now another thing you check for during the technical evaluation of mechanical data sheets before you procure your centrifugal pump is that you check for practical feasibility of the pump by calculating the pump shut-off head. The concept of pump shut-off head has been discussed in our previous session. So if you are yet to listen to the pump shut-off head explanation, you can check through the YouTube channel, for the session on shut-off head and the pump head calculation. So during the technical evaluation of centrifugal pump mechanical data sheets, another thing you have to check for is the practical feasibility of the pump, by calculating the pump shut-off head. Now the question is, how do you calculate the pump shut-off head? The shut-off head is calculated as the maximum head at rated impeller, the sum of the maximum head at rated impeller and the maximum suction pressure. Don't forget, your shut-off head will be determined by the expression of the sum of maximum head at rated impeller and the maximum suction pressure. So this is the expression for the what? For the shut-off head. Okay? Now, by calculation, we said shut-off head is the maximum head at rated impeller. Now, the maximum head at rated impeller must have been given by the pump vendor, which will have been stated on what? On your mechanical data sheet. If the maximum head at rated impeller diameter is not stated on the mechanical data sheet, you have to comment on the mechanical data sheet that please supply the maximum head at rated what? At rated impeller. And then you look at your what? Your maximum suction pressure, which you must have given on your what? On your process data sheet. So in this case, let's look at what we have in our example that we have here. So look here, you have your shut-off head to be maximum head at rated impeller. So you come here, okay? You come here, what is your maximum head at rated impeller? Now, as you can see here, your maximum head at rated impeller is what? 127.7 meter. Take notes. So this is your what? This is your maximum head at rated impeller. So it is important that a particular vendor, for a particular pump you are about to procure, they must have provided this information on the mechanical data sheet, because these are some of the information you require to do a thorough technical evaluation of the mechanical data sheets before the pump is going to be procured. You don't want to be the engineer that will procure equipment that will be noisy. You don't want to be the engineer that will procure equipment that will run within a short period of time, and then the vibration level will be excessively high. So it is very, very important for you to do a thorough technical evaluation during detailed engineering exercise, before you finally decide on a particular vendor to go for, based on the criteria, based on how much they have been able to meet up with the criteria, the clauses specified in API 610. So in this case, the maximum head for the rated impeller diameter is what? At rated impeller diameter is 127.7 meter. Now, if you look at this, the maximum suction pressure. Now, your suction pressure is going to be part of your operating condition. So in this case, your suction pressure, you can see 0.3 is normal suction pressure. Now 2.46. Now take note of the units. Here, the maximum suction pressure is expressed at what? Kg per centimeter square gauge. So which is 2.46 kg per centimeter square gauge. So what you will do next is that let's go back to what we have. Okay, what you will do next is, don't forget your maximum suction pressure is in kg per centimeter square gauge. So you need to first convert it to meter by using this expression. So your pressure in kg per centimeter square gauge, you use the expression the head in meter multiplied by what? By the specific gravity, which you as a purchaser must have supplied the vendor, okay, over 10. So you use this expression to convert your maximum suction pressure in kg per centimeter square gauge to meter. So if you use this expression, you put 2.46 equals to your head in meter times your specific gravity. Your specific gravity in this case, you check your what? You check your what's it called? The mechanical data sheet. The specific gravity is 0.66. Okay, all right. So your specific gravity is 0.66. So with this expression, you get your maximum suction pressure in meter to be what? 37.27 meter. So with your maximum head rated impeller, diameter in meter, and your maximum suction pressure in meter, so your short of head is going to be 127.7, don't forget, in meter, plus 37.27 in meter. So you have your what? Short of head to be 164.97 meter. You can as well convert it to what? You can as well convert it to kg per centimeter square gauge with this same expression. So if you use this same expression to convert the short of head in kg per centimeter square gauge, you are going to have your short of head to be what? To be 10.88 kg per centimeter square gauge. Now, this is very important. What I'm about to mention now is very important. The essence of calculating your short of head, for a particular pump you are about to procure, is that you are going to check the short of head that pump vendor is about to supply to you. You are going to check it against your downstream design pressure. Okay, now because the maximum short of, considering the maximum suction pressure including all tolerances shall not exceed downstream design pressure. Let me repeat this. Your maximum short of head considering maximum suction pressure including all form of tolerances shall not exceed your downstream design pressure. If your short of head, by the time you calculate your short of head and it exceeds the downstream design pressure, don't accept the pump. Now let's check our downstream design pressure in this case. Okay, let's check our downstream design pressure. Our downstream design pressure, you see it, you must have specified it. Now your downstream design pressure is 14 kg per centimeter square gauge. Don't forget, I said your short of head, shall not exceed your downstream design pressure. So in this case, what is our downstream design? What is our short of head? Let's go back to the presentation. Okay, the short of head is 10.88 kg per centimeter square gauge. So your downstream design pressure is 14, so which means it's okay. But in a case where you have your short of head greater than your downstream design pressure, so it means is not meeting the condition, so you don't accept it. So you have to comment on the mechanical data sheet that note your shut off head, is greater than your downstream design pressure. Please review. Okay, and you wait for the response of what? You wait for the response of the vendor. All right. Now, another thing you need to check for during the technical evaluation of centrifugal pump mechanical data sheet is the concept of the pump suction specific speed. Okay, the pump suction specific speed. Now, the pump suction specific speed, don't forget, shall be calculated in accordance with Annex A as specified in what? In API 610. The concept of pump suction specific speed has also been, extensively discussed in one of our sessions that we've had in the past. So if you are yet to listen to the pump suction specific speed video tutorial, please check the YouTube channel. That's why I advise you subscribe to the channel, so that anytime we upload the sessions, you can always get notification. So another thing you check for during the technical evaluation of centrifugal pump, is that you check the pump suction specific speed, in accordance with Annex A as stated in API 610 with this expression. Now, your pump suction specific speed, okay, is expressed as your NSS, to be equals to N, which is your rotational speed in RPM, and your Q, this particular Q, is your flow rate, or you can call it what? You can call it your pump capacity. Okay, you can call it your pump capacity. So it's going to be your Q is going to be your pump capacity at BEP. The BEP is the best efficiency point flow rate. So your Q is going to be your best efficiency point flow rate. Okay, the next thing will be your NPSH at BEP also. So once you have this value, your NSS is going to be expressed as what? As N multiplied by your Q, which is your flow rate at best efficiency point. Don't forget I mentioned that your best efficiency point is that flow rate at which your pump is having what? Is having the maximum efficiency. So when you check your pump curve, that tip on your efficiency curve, where you have the maximum efficiency, so when you trace it down to your pump capacity on the horizontal axis, so your best efficiency point flow rate, you put it here, at your NPSH 2. So the value you get, that will be your NSS, which is going to be your what? Which is going to be your pump suction specific speed. Now if you look at what we have here, okay, for the pump curve, you have look at this particular pump curve. Now you have your what? In this case, look at your efficiency curve. Don't forget I said your suction specific speed is expressed as your N. N is the rotational speed in RPM. Okay, in this case your N is what? Your pump speed is 1485 RPM. So when you come here to get your Q at BEP, now this, you take your efficiency curve. Now the points on the efficiency curve where you have the maximum efficiency, that tip, when you trace it down, okay, when you trace it down, your tip here, your best efficiency point flow rate it's going to be somewhere here. So it's going to be around 450, 456, cubic meter per hour. All right. So this is going to be your Q at BEP. Now, as you are tracing it down, don't forget this is your NPSH line. This is your NPSH line. Now, the point at which it touches your NPSH, you trace it, to the right side to meet the NPSH vertical axis. This is the NPSH vertical axis. Okay. Now, the NPSH at BEP is going to be what? It's going to be around 2.4. Don't forget, as you are tracing your best efficiency point flow rate down to touch the flow rate line on the horizontal axis. Now, where it touches the NPSH curve, you draw horizontal line towards the right, on the vertical axis to meet the NPSH. So where it matches the NPSH on the vertical axis here is going to be your what? It's going to be the NPSH at BEP. So it's around 2.4. So now you have your N to be what? To be 1485. Okay. You have your the best efficiency point flow rate to be around 455 cubic meter per hour, and you have your NPSH to be 2.4 meter. So when you put this expression, okay, your suction specific speed will be around 14,092 for this particular pump. You can check. However, you see, the most commonly used hard limitation for pump suction specific speed is 11,000 US units. Now, another thing that is very important here is that, because people always make this mistake when you are calculating your pump suction specific speed. Now, this expression with your N in RPM and your best efficiency points. Okay, let's go back to the presentation. Okay, now with your N in RPM, your Q in cubic meter per hour, and your NPSH in meter, to get this NSS in US units, you are going to multiply it by what? By 51.64, 51.4 rather, over 60 to get it in what? In US units, in USC units. This, let me repeat this. If you use your N in RPM and you use your Q in what? In cubic meter per hour with your NPSH in meter, this expression must be multiplied by 51.4 over 60 to get it in what? To get it in USC units. So, and I told you that the most commonly used hard limitations for pump suction specific speed is 11,000 US units. And don't forget, the suction performance of a centrifugal pump is an extremely important consideration for optimal pump performance. Okay? Now, by the time you calculate your pump suction specific speed, there is a widely accepted, hard limitation for pump suction specific speed that once is greater than 11,000 USC units, the tendency that the pump will be susceptible to what? High vibration is high. So that is why it is widely accepted that a pump vendor should try as much as possible to have, the pump suction specific speed, to design a pump with a pump suction specific speed less than that 11,000 what? 11,000 USC units. Okay? Now, another thing that you need to also check for, okay, in this, during the technical evaluation of a centrifugal pump, as per API 610, is that if you look at some of the basic design conditions as stated in API 610, it is stated there that the pumps shall have a preferred operating regions of 70 to 120% of best efficiency flow rate of the pump as furnished. Now, at the same time, your rated flow shall be within the region of 80% to 110% of best efficiency flow rate of the pump as furnished. So when you receive your pump mechanical data sheet and the pump curve, you need to check whether a particular vendor is meeting this condition, this clause as specified in API 610. All right, the concept of preferred operating region has been discussed in our previous session. So if you are yet to listen to it, you can as well check the channel to see the concept of preferred operating region and the allowable operating region. All right, so now if you look at the pump curve, on your pump curve, you are going to have what? You are going to have your preferred operating region being stated. Now look at this. This is a particular pump curve. Now on the pump curve, you are having preferred operating region. Look at this. From this arrow to this arrow, this is your preferred operating region. All right, so in this case, your preferred operating region is somewhere from 319 cubic meter per hour to 500 to 501 cubic meter per hour. So your preferred operating region is between 319. Okay, look at this. It must be stated on the pump curve. Your preferred operating region must be what? Must be stated on the pump curve, because you are going to check the preferred operating region with respect to your what? With respect to your best efficiency point flow rate. Now don't forget, we said your best efficiency point flow rate is around 456. Okay, now you check your preferred operating region, both sides, with respect to your what's it called, your best efficiency point flow rate. Okay, so now if you look at what you have in this case, 319 equals to 319 is what percent of the best efficiency point flow rate. So you get that. Now 501, which is the upper limit of the preferred operating region, is what percent of the best efficiency point flow rate, is what percent of 456. So by the time you do that expression, you check whether that preferred operating region is between 70 to 120% of the best efficiency point flow rate. If it falls outside this, then you have to comment on the pump curve or your pump mechanical data sheet that please review, and you wait for the response of the vendor. So these are the things that you need to check for during the technical evaluation of your centrifugal pump before procurement is done. You have 10 pump vendors and you need to select the best. So these are some of the things that you check for with respect to API 610, which is the standard governing the basic design of centrifugal pump. So if a particular vendor is not meeting a particular clause, then you have to comment on the what? On the data sheet for the vendor to review and then send you another revision of the data sheet. Okay, now another thing that you also need to check is the rated flow. Now if you go back to the slide, we said the rated flow shall be within the region of what? 80 to 110% of the best efficiency flow rate of the pump. Now if you look at your rated capacity, don't forget, you must have specified your rated capacity on the process data sheet for the vendor. So now your rated flow or the rated capacity with respect to the best efficiency point flow rate, which is the flow rate at which the pump is having the maximum efficiency. So the API 610 is saying that your rated flow or the rated capacity shall be within the region of 80 to 110% of the best efficiency flow rates that the vendor is supplying to you. So if your rated flow falls outside this range of 80 to 110%, then you have to ask the vendor that please review and get back to me and wait for the response. So if it's not meeting, that means the decision is now yours. So these are some of the things that you need to check for during the technical evaluation of what? Of mechanical data sheet for a particular centrifugal pump. So you check some of these clauses. There are a lot of things that you need to check for, stated in API 610. So for today, this is where I'm going to stop. So in the next session, which is going to be part 2, so we are going to continue with some other things that you also have to check as stated in what? In API standard 610, which is the standard governing the basic design of centrifugal pump. Okay, so this is going to be the end of the part 1. So if you are yet to subscribe to this particular YouTube channel, please click the subscribe button and like some of our videos, so that in the coming weeks, as we upload other sessions, you can always get notifications. So thank you very much for your time.